From the previous exercise, we had these numbers, and someone requested a hint from them. This first one, you look at the figure, they ask you to measure and state the length AB, AD, and DC. Construct the figure below accurately. So when you observe the figure, you'd realize that it is made up of triangles. And when we looked at triangles, we looked at triangles of how they can be constructed from different ways. But you can see that if I have ABD as a triangle, and BCD also as another triangle, ABD is a triangle when they have given you the base angles and the altitude. So after constructing triangle ABD, then you construct triangle BDC. BDC is a triangle when they have given you the base, the vertical angle, and the altitude. Okay, the base now will be, after constructing ABD, now BD will be the base of triangle BCD, and this one will be the angle that will be directly opposite to this side. So this one will be the vertical angle, and this length BC will be the length. So let me take it here and I look at it in brief. So this is the figure here. So remember we said that you start with first start with constructing this triangle ABD. ABD can be constructed very well. Remember you don't know the base. You will know how to construct this from triangles. We say that draw a line here, horizontal line here, make it of any length. Then after that, stand at this point and construct a parallel line. We also discussed the methods of constructing a parallel line using this distance 52 as the distance between those two lines. So if I measure distance 52 and I construct a parallel line, I will not use the method you already know, because I know that you know how to construct a parallel line. You stand here at any point on the line, then you begin drawing arcs of that distance along the line, and then you join them using a straight line. Those ones you already know. So I will stand now at any point on this line and I construct an angle 45 degrees. So I will not bother constructing 45 degrees because I know you already know how to do that. So here I will construct 45 degrees at any point. Okay, so at any point I construct the angle 45 degrees here, so that is 45. Okay, so after constructing 45 degrees, then I will check where the 45 degrees has intersected this parallel line I constructed earlier. Okay, remember this angle that is here, the base should be 60 degrees. So here we use the concept of alternating angle. When you construct 60 degrees here, it's like coming here, you draw an arc of any length, then using the same distance, you come and you construct the same value there. So it means that from this point through this point, you have a line that will go up to the base there. So you have there an angle of 60 degrees. Okay, I didn't want to construct it, but since I have constructed it, let's proceed with that. So you have this angle 60, and that angle which will be there will be as well 60. So you already now have the figure ABD, which is given. Angles at the base are 45 and 60, and the altitude is 52 degrees. You can even take off this, or you can rub it a little bit slightly, or you make it faint, and then you have the triangle here ABD perfectly. So it means that this BD is going to act as the base for triangle BCD. So triangle BCD, we looked at triangle, how to construct a triangle when you are given the base, the vertical angle, and the length of one side, which is triangle BCD trying to put forward. So that's what we are going to do exactly we are going to construct BCD in that same sense, whereby we shall come down here and we construct the vertical angle down along the base here. So that's what we do. We shall come at the base here, at the base, either this side or this side, you construct an angle which is equivalent to the vertical angle. So since the vertical angle is 60 degrees, so we shall construct an angle of 60 degrees. Okay, we shall construct an angle of 60 degrees, and that's what I'm going to construct there, 60 degrees. So you can see that when I measure, the angle between this is 60 degrees. So I've constructed 60 degrees there. That is an angle to the base of triangle BCD. So after constructing 60 degrees, I will come and I bisect. I'm going to bisect the base of triangle BCD. So how do I bisect? I will also not use the methods you already know, but I know that you know how to bisect that side BCD. I've drawn a bisector. Okay. After drawing the bisector, then I'm going to extend this line such that I construct a perpendicular here. Okay, so that's what I'm going to do, but me, I'm going to just do a perpendicular. I know you understand when you are drawing yours there in your figure. So this is a perpendicular, it is 90 degrees to this and this line. So this is 90 as a perpendicular. So you note where the perpendicular intersects with the bisector of the triangle. So the perpendicular and the bisector are intersecting here. So where they intersect from, I use it as the center, it's straight to the limits of the base, and I draw a circle there. Okay, and that circle will help you determine the rest of the other points that are remaining on the figure. So after that, I will now measure this distance from B here on the circle to get point C. So that distance is 42. So I will come here, because B is there, then measure 42, then I draw the circle. So where that touches the circle, I will be just joining this point to the other point already on the base, and also this point to this one. So when I join all the figure like this, that one will be the figure ABCD, which is given and required. So this one will be the figure ABCD. So that was the first figure.